Okay, today we're going to look at a couple examples for different heat calculations. Remember, we've got two different formulas that we can use, one dealing with temperature change and one dealing if there's no temperature change. So let's look at this problem. It says how much energy is needed to heat 9 grams of water from 25 degrees Celsius to 85 degrees Celsius. And remember, I always say the first question that you should ask yourself, ask the question, is there a temperature change? We use the delta to mean change so that you know, is there a temperature change? And in this case we do. We have 25 degrees to 85 degrees. With that, since we're going to say yes to this question, we're going to use the formula Q equals mass times change in temperature, there's the delta sign, times specific heat, CP being specific heat capacity. In sometimes you will see this as a lowercase q. It doesn't matter, it means the same thing. So let's look and see, do we have all the information? Do we have mass? In this case we do. So we can put 9.00 grams. Do we have a change in temperature? Well, 25 to 85, so we can subtract that. And I'm going to put 60. I'm going to put a decimal point there because we've got two significant figures, degrees Celsius. And then this is going to be specific heat. But if we look at the problem, we don't have a specific heat. But we do know that it's water. So one thing that you're going to have to memorize is that for liquid water, and you ask, how do we know it's liquid water? Well, it's from 25 to 85. We know that the melting point or freezing point of water is 0 degrees Celsius. We know that the boiling point is 100 degrees Celsius. These two temperatures fall in between, so we know it's a liquid. So liquid water, the specific heat of liquid water is 4.18 joules over grams degrees Celsius. So we can use this right in our formula. 4.18 joules over grams degrees Celsius. Look through, notice grams is going to cancel with grams, Celsius with Celsius, and we're left with joules, which is how we're going to get this energy. Multiply everything across. I can put a Q here so we have that. Multiply everything across, and you should get 2257 joules. We're going to go back and figure out our significant figures. So we have 3 significant figures here, only 2 in this case. So we're just going to have these 2 as our significant figures. One place past it to round. Our final answer is going to be 2,300 joules of heat. So that's how we solve our first problem. Now let's look at another problem. Let's go over here and read the problem. What is the specific heat of a 22.8 gram sample of a metal? So in this case, we don't know what metal we're using. That absorbs, takes it in, 1,450 joules of heat from 21.8 degrees Celsius to 75.0 degrees Celsius. Well, again, we're going to ask the question. What's the question? Is there a temperature change? Okay, make sure you ask this question. We're going to answer yes again because we're going from 21.8 to 75. So we know, since we answered yes, Q equals mass times change in temperature times specific heat. I would write out your equation every time. Check and see which pieces of information you have from the problem. We have mass, check. Change in temperature, we'll figure it out, but we have it. Specific heat. We're trying to find specific heat. Do we have Q? We do. So we need to rearrange this formula to solve for specific heat. To do that, multiply both sides divide both sides by delta T times the mass. So I'm going to put it on this side as well. Just algebra 1 cancels out. So we get Q over M times delta T equals specific heat. And that's what we're looking for. So now let's put the information in. We have Q given to us in the problem right here, 1450. So I'm going to go 1450 joules over, and remember, we're looking for specific heat. So what are the units for specific heat? Joules over grams degrees Celsius. So our final answer should have that. So we have 1450, mass given to us in the problem, 22.8 grams. Temperature change, we're going to subtract these two, and you should get 53.2 degrees Celsius. We have joules over grams degrees Celsius, just like we're looking for. We've got the top divided by the product of bottom, so multiply these two together first, and then we're going to do 1450 divided by this, and you should get an answer of 1.2 joules over grams degrees Celsius. And this is going to be your final answer. Now, if we go back and we look, this is 3 significant figures, 3 significant figures, 3 significant figures, 3 significant figures. So we're going to have to add a 0. Doesn't change the amount, but it does show us 3 significant figures. So that's going to be your final answer. We could look this up and find out what actual metal we're talking about. 1.20 for the specific heat, and that would be our intensive physical property. We can identify what metal we have. And that's it.